So for our next experiment, what we're going to do is we're going to measure spatial resolution. Spatial resolution is measured with certain tools, right? These are going to be known as line pairs per millimeter spatial resolution test tools. So I have 3 different types. This one, you can see that we have a bunch of lines, right? And they're going to blur together at a certain point. You're no longer going to be able to make them out, and then that would be the spatial resolution. I feel like this one is extremely subjective, so I show it to y'all, and then I'm like, all right, we're not going to use this one. This one is known as a circle line pairs test tool. You can see again at a certain point all of the lines kind of blur together, like right here in the middle, and then you can no longer make it out. I can't figure out how we use this to measure spatial resolution, so it's not very objective to me, so again, I don't use it. But I have seen this question on a registry. They have shown different tools and they've said which one of these can be used on looking for spatial resolution. So they might use this with like the pentometer step wedge, or maybe they would throw like a boomerang filter in there or something like that. So you do need to be able to identify all of these different types of tools. But the one that we're going to be using today is this line pairs per millimeter test tool. So you can see that at a certain point, sorry, it's my nail, it's got numbers at the bottom. You see that? Yeah. Right? Like that? Is that better? Okay. Is it backwards? No, it's good. So, especially at the 2.0, you can definitely make out all 5 lines, right? But as you get a little bit down further, they start to blur together and it becomes like just a mass of gray, right? So what we're going to do is we're going to take some x-rays and we are going to see, it is kind of subjective, right? I usually just do like a mass majority. Whoever says like, oh, I can see 4.0, and I'm like, okay, we're going to go with 4.0. The whole point is just to see how it changes, not so much the exact number that it is. So plus our monitors are not the best monitors, so our spatial resolution on our image receptor could be better than what it actually is on the monitor. And we're trying to make out these fine lines in like this very bright room, which is, remember, a lot of extra light is known as noise. So it's blocking our ability to see it really well, just like having, somebody has a bright light on in a movie theater, you wouldn't be able to see the movie as well. So it's the same concept. So I'll show how we're going to set up this one, but these are our 3 spatial resolution test tools. All right, so we took a picture of our finger and our resolution test tool. We used 53 at 2.8. It gave us a dose of 16, DAP of 16. EI is 254, giving us a -3. Again, if I shoot a -3, what's the best way to fix it? Bring up KVP 15%, right? So I brought it up to 62. It's a little bit too high still. Brought it down a little bit. 61. We're going down a little bit. Bring it down to 60. There we go. We got our perfect picture. So 60 at 2.8 is going to be our perfect picture. Now, all I've been doing is changing my visibility properties, right? I've just been changing my technique, my KVP, and my mass, which is just going to be changing my IR exposure and contrast. If I change KVP, does it change the size of the body part? No. Does it change my ability to see fine detail? No. Now I need to have the ability to see fine detail by having an adequate technique, but it does not change the amount of resolution that's actually on this image. I'm going to go back to this other picture just because, no, I'm going to leave it on this one. So to be able to measure our spatial resolution, what I would have students do is zoom in as much as they can on the spatial resolution test tool. There's a little magnifying glass on the side that I clicked. This is going real slow. That's cool. And then we grab the little hand here and I move this around. All right, so again, this is kind of subjective. So at a certain point, you have to tell me when you can no longer make out all 5 lines going down the whole entire test tool. So I can see all the lines at 3.55. I can see all 5 lines at 4.0, 4.5, kind of. Yeah, kind of. It starts to kind of get a little crisscrossy. But 5.0, I can't make out the lines anymore, right? So I I'm not sure how well this is going to translate onto my phone for you guys to be able to see. Let's go with 4.0 just because that's normally what the students pick, and I'm totally okay with that. So we're going to say that our spatial resolution is 4.0 line pairs per millimeter, meaning we're going to be able to see a spatial resolution of 4.0 on this exam. I'm going to zoom back out. So on your experiment sheet, we already took our picture, we shot a 0, but all we've been doing is changing technique. And so by changing technique, all of these pictures that we have taken, all of the rest of these pictures will still have a spatial resolution of 4.0 because all we've changed is KVP, and KVP does not affect spatial resolution. Okay, does that make sense? So even on our first picture that was underexposed, right, the -3, if I were to zoom in real good on this guy, 10 hours later, even though it's underexposed, it is still the same line pairs per millimeter, still the same spatial resolution. I'm gonna still go with 4. I can still kind of see 4.5 again, but we'll just go with 4 because I'm sure this isn't recording as well as I can see it. So we'll go with 4 on that, and we're going with 4 on this. So every single one of these pictures had a line pairs per millimeter of 4.0. Now we need to measure our finger to be able to see how much magnification factor we are. That's what the MF is on your lab sheet. So we need to figure out the image size and then be able to figure out our magnification factor. So to do that, I'm going to take this ruler and I'm going to click on one end. Sorry, the ruler tool's right there. I'm going to click on one end, bring it across to the other end. Okay. That's going to give me a measurement of 8.88. Now remember, again, this can be subjective, right? I could measure it from here to here or from the bottom of the finger here. I mean, it's going to basically be similar numbers, but in this case, it is showing that we do have magnification, right? Remember the finger when I measured it initially was 7.5. So now we have to do our magnification factor. So to do magnification factor, it's image size over object size. So our big over little, right? Our object size is going to be 8.8 divided by 7.5. And that's going to give me a magnification factor of 1.17. So this picture right here is going to be like 117% more magnified than it is in real life. And this again is with no OID, right? And it's just as low as OID as we can. We still have a magnification factor of 1.17. Now what we're going to do is purposely create more magnification factor by adding more OID. God, those windows are disgusting. All right, so now I have added 3 2-inch sponges to create a total OID of 6 inches, right? So if I'm still shooting at 40 inches, remember we're always looking at this number, if I have a 40-inch SID and now I have a 6-inch OID, that means from the X-ray source down to the body part is going to be our SOD, source to object distance, is now going to be 40 minus 6, 34 inches. So now we're going to have magnification. But again, I have massive OID. So talk me through what's going to happen. X-ray is going to come in, it's going to hit this, and it's going to start scattering. As soon as X-ray hits anything, it scatters, which means if I had my 0 technique, will this picture have another 0 technique, even though I have this huge OID? No, this is known as the air gap technique, basically, right? So I'm going to have, because of this huge OID, scatter is going to hit this and scatter and miss the image receptor, which means IR exposure is going to go down. Because scatter is missing the IR exposure, what's going to happen to contrast? Contrast is going to go up, right? Because I have this huge OID, what's going to happen to distortion? Well, this is going to get very magnified, right? As I get a higher and higher OID, I'm going to have more magnification, which means that spatial resolution is going to go down. So we are not going to be able to see the 4.0 line pairs per millimeter again. Also, because we are now having this huge OID, and I just talked about distortion, is this going to be size or shape distortion? This is going to be size distortion, right? Remember, shape distortion comes from either the part being angled or the tube or the IR being angled. But if I have just OID, that's going to cause magnification, which is going to be causing size distortion. So now our finger is going to get bigger. All right, so here is our zero picture. Remember 62.8, we ended up getting a measure at 8.88 centimeters with a magnification factor of 1.17, and we all agreed, because I said so, that we all saw 4.0 line pairs per millimeter when we were zoomed in. So now I'm going to show you what happens when I take this picture with this huge OID. It's going to be this picture right here. Boom. First off, you can immediately tell how much bigger it is, right? Yes, it already has a measurement, but I'll take care of that. So all the things, right? Let's talk about all those things that's going to happen from an increase of OID. When I have an increase of OID, using the same technique, notice that my EI and DI go down, because as soon as X-ray hits anything, it scatters and misses the image receptor, meaning that scatter is going to be down here instead of on my image, which means this picture should be higher contrast, shorter scale, right? The measuring. So if we want to figure out our magnification factor, we have just hit this ruler tool and measure from one point to the next point. This is going to see 10.56. So if I were to want to know my magnification factor, big over little, 10.56 divided by my actual size, which remember that was 7.5. And that's going to give me 1.408. So my magnification factor by adding this OID has gone up from 1.17 to 1.40. So we have more magnification, which is more size distortion. And if I have distortion, what happens to spatial resolution? Remember, they're always inverse. So now I'm going to zoom in on this guy. Move this over. So can you still make out the lines at the 4.0? Right? You can't. I hope you can, or else you have better eyes than I do. But we can kind of still see 3.55, even like 3.15. Do you see how like spatial resolution has changed so much by just adding OID, right? So I'm going to say, because I get to make the decisions here, I'm going to say that our spatial resolution went to 3.15, because I can definitely see all 5 of those lines. It starts to get kind of a little bit blurry here at the 3.55. But it definitely is not the 4.0 like it was before, okay? So if we have distortion, right, if we have OID like out there, how do we fix it, right? So think of the flashlight, right? If I have OID, the best thing I can do is back up my SID, and therefore I'm going to have a larger SOD, and I'm not going to have as much magnification. Watch and learn. Okay. So now I've brought my tube up as high as it goes, and it says 45.6, but I know that is not correct because I also brought the table as low as it goes. Notice that I still have that 6-inch OID of the sponges, right? But there's no way it's 45. It says 45 because it thinks that the table is at radiographic height, which in reality I brought it way down, so it is not 45.8 anymore. So what I need to do is take the tape measurer out, measure down to my table, and that's going to give me an SID of about 50. Okay. Now, when I back up my SID, what's going to happen to, let's talk about all the things, right? First off, do you notice that the size of my collimation has gotten larger, right? Remember the Post-it notes? As you back up SID, the field view gets bigger, but it's going to lose intensity. So because I don't want to mess that up, I'm going to increase my collimation just a little bit, make it a little bit tighter so it's similar in depth as it was from the original picture. Part 2. if I add SID, what will happen to IR exposure? So when you add IR exposure, or I'm sorry, SID, right? Now I'm at a 50-inch SID. The field view size is going to get larger. That's why I just increased collimation. But in the process, it's going to cause a decrease in intensity, right? That would be inverse square law, but we never do inverse square law, so we don't have to worry about that. So because I'm backed up so far, you'll notice that the intensity on the finger is less than it used to be, which means IR exposure is going to go down. Let's talk more things. By adding SID, what's going to happen to contrast? Oh boy. Okay, so this is where I usually lose people, right? By backing up SID, there is no change in contrast. A wave is a wave is a wave, right? So I picture the KVP wave. It's not like I ever have the wave and it's like really high frequency, short wave, and then it slowly becomes a longer wave and lower frequency. The KVP wave is still the KVP wave. So by adding SID, it's still going to be the same KVP wave. It's still going to be the same contrast. The difference is the intensity is going to go down. So our photographic properties, right? It's going to be less intense. The IR exposure is going to go down. However, contrast still going to be the same. So OID causes scatter, which means that the scatter is going to miss the image receptor and it's going to be a more black and white image. But SID does not change how much scatter is being produced and hitting the image receptor. It is going to change how much intensity is hitting here, right? But if I compensate with DSL, it should be the same intensity. Let's talk through more things. By backing up SID, what's going to happen to distortion? So I still have my 6-inch OID, right? So I'm still going to have some magnification, but because I have now a much larger SID, it's going to help reduce that magnification, meaning that the magnification factor is going to go down, the size of the finger, the bone is going to go down, but the spatial resolution is going to get better. This is why, for example, I take all my x-rays where I work at the hospital at 45 inches. That's our protocol. Because we already know that at 45 inches, we're going to have less magnification and therefore spatial resolution is going to improve. Why do you do a chest x-ray at 72? To reduce magnification of the heart, right? And therefore providing better spatial resolution of the lungs. So I'm talking about two different things here, right? We've got IR exposure and contrast, our photographic properties, visibility properties, and then we have our geometric properties, our spatial resolution and our distortion. And we need to talk about adding SID, how it's going to change our distortion. So we said that by adding SID, the finger is going to get smaller. It's not going to be as magnified. Spatial resolution should go up a little bit. But because I'm not going to do direct square law, this increase of SID is going to cause me to drop IR exposure. Contrast will not change, okay? So increase of SID, right? So when I increased SID, again, if I click on this guy and move this, we can see it a little bit better. You'll see that again, the technique is still the same, 60 at 2.8. I have not compensated for this change in SID. So I have this huge SID and I'm still taking it at the same mass, which means my DI is going to be very underexposed. So the next picture we're going to do after this is going to be doing DSL to correct for this DI of -3. But in the meantime, let's do all the rest of the stuff we have to do. So the one thing is we have to measure our bone. You can see that they already did this here. So if I click on this and measure from the edge of one bone to the edge of the other side, our measurement is now, oh, that looks blurry, 9.93. Can you see that? I hope so. 9.93. Okay. Remember our last picture had a magnification factor of, pause, unpause. Okay, I totally knew what I was talking about. By adding SID, now our finger is going to go down to 9.93, meaning that our magnification has gone down compared to when we just had that OID, and it was 10.56, right? So by adding SID, I am going to cause my finger to get smaller, right? In addition, well, let's finish this part really quick. By changing my SID, but still having my OID, having this huge SID over here, huge SID, but still having my OID, the finger isn't as big, right? Let's do magnification factor and find out. So again, 9.93 divided by our original finger size of 7.5 gives us a magnification factor of 1.324. 1.324 is going to be less magnification factor than it was when we had the OID, which was giving us a 1.408 magnification factor. So by backing up SID, we have reduced the magnification of the finger, of the bone, which means distortion has gone down, which means what happened to spatial resolution? Slowest thing ever. When we had OID, we said that the best we could see was 3.15, right? But do you see how now I can make out the 3.55 again? I can see all the 5 lines here, right? So by adding SID, even though I have OID, I have improved my spatial resolution because my finger isn't as large or distorted. So distortion has gone down to 1.408 magnification factor. My finger is not nearly as large as it was on just straight OID, but remember, we still haven't corrected for this change in distance and the change in intensity. So that's when we do direct square law. So direct square law is going to be set up as 2.8 over x equals 40 squared times 50, or I'm sorry, over 50 squared. Do that. It looks like our new technique to compensate was about 5 mass, right? I'm not sure 100%, but that's okay. But all I've done now is compensated for this change in SID by doing direct square law. I haven't touched anything. All I've done is change my technique. And you'll see that now my EI is 400, my DI is still a little underexposed, but I do still have that large OID that I haven't compensated for. But basically it brought it closer to a 0 technique compared to the -3 that it was before. Now, by changing mass is the only thing I've changed here. Did the size of my finger change at all? No, right? So if I measure, it's not going to be exact because, I'm not measuring the exact same spot anymore. But basically, it's the same size measurement, right? Oh, breaking it. 9.7576, right? It was 10 point, what was it on the last one? 9.93. But again, oh look, see, they started their measurement there. Okay, well I can do that. Okay, I can do that. We'll start our measurement here and go here. 9.91, there you go. So basically, the magnification has not changed. All I did was change mass to compensate for this change in SID by doing direct square law. So the size of the bone is still the same. By just changing mass, will my spatial resolution change? Remember, that's the only thing that has changed between this picture and the last. Well, our bone is basically the same size, right? Obviously, room for error for me not clicking the exact same spot again. But we should still see our spatial resolution at 3.55. Yeah. Again, just changing mass only affects our IR exposure. It affects nothing else. It does not affect distortion. It does not affect spatial resolution. Nada. Okay. Okay, so finally, to really show huge OID, I brought my table back up. I'm back at 40 inches. But now what I've done is I've actually taped this finger. Again, like I said, if you see this in real life trauma, please don't ever do this. You can see how incredibly magnified this image is, right? So I know that distortion is going to go way down. I'm not going to try to tape the spatial resolution test tool on there, but you could, as you imagine, distortion's that large, spatial resolution is going to go down. So literally what I've done now is I used my tape measure to measure down, and I came up with about a 20, it's not quite there, but whatever, about a 20-inch OID SOD. So it should be 20 inches from here down, and it should be 20 inches from here to the x-ray tube, right? So without even doing this problem, right, you should be able to talk your way through this. If my body part is halfway between my x-ray tube and my image receptor, how much magnification factor should I have? This is the kind of stuff you need to do for Quiz Bowl. Like, they're going to give you these kind of problems that you should be able to do in your head. So if my SID is 40 and my SOD is 20, right? SID over SOD, that's going to tell me it should be about a magnification factor of 2, which means that my magnification factor, this finger should be about 200 times bigger than it was initially. So if initially it was 7.5 centimeters, because of this huge amount of OID, we're going to now have, I'm going to guess that that's going to be about 15, 16 centimeters, right? It's literally going to double the size of the actual size on the image. All right, so we're back at our 40-inch technique. Now, notice that the EI and the DI are going to change, but I don't care about that. The whole point of this part is just to show you spatial resolution and distortion. So I want to show you that at a 20-inch OID or a 20-inch SOD, our fingers should double in size, right? So it was 7.5 in real life, and then notice that it went up to 16.65. It's almost 2 times bigger than it was, right? Remember I told you? So 16.65, is that what I said? Yep. Divided by the 7.5 that initially was, gives us, like I said, a magnification factor of 2. So we are at 222% magnification on this picture than we were in real life, right? Now, are you ever going to tape a bone halfway through the x-ray tube in the table? No. But if you were to have that huge of an OID, this is when you should know that you should back up SID to compensate, okay? Obviously, your finger's not going to be taped to the bucky or to the tube, but nonetheless. Okay, and then the final part is just showing how movement is the #1 enemy of spatial resolution. So what we do is we do law of reciprocity to create a very long time so that we are more likely to see movement on the x-ray. And then I come out here, very morbid stuff. I'm going to tap the finger. Oh, it's moving, right? And then while that's going, I'm going to take an x-ray. It's not going to work because it's not really on. And then as we take this picture with the movement, do you see how we have lost spatial resolution? We have movement. The #1 enemy of spatial resolution is movement. Focal spot size only affects spatial resolution, but it's not the #1 factor affecting it. There is nothing I can do to this picture to make it less blurry. I don't even have the whole finger in there, but that's okay. This picture, way more detail, right? Because I don't have movement. This picture, way less detail because I have movement. And remember I said, anytime we talk about movement, we're going to talk about that lateral motion, because otherwise we add OID, which is going to change our distortion, and it's going to change our IR exposure and contrast and all that. But if we just have lateral movement, right, it is going to absolutely destroy the image, and we are not going to have any spatial resolution. Hopefully that was good for y'all. Please leave feedback, and I will show one more on elongation and foreshortening.